Hey everyone, so I want to do a really quick video where I just kind of go over some of the terminology that the AP uses within the test. The reason I want to go over this is because there are certain phrases that, while on the surface or the way that you probably read them, seem like they're saying the same thing. What they actually do, though, is they provide very specific criteria that you have to answer with. Uh, if you try to answer a certain question using equations, they may not allow that because of what they say. So that's kind of what I want to go over this with you. So this is pretty much doing the same thing. Basically, one thing that you want to realize is you want to try and keep a lot of your wording, a lot of your answers to try to be very concise and specific. Try not to give too much information because you might end up in a situation where you accidentally say the wrong thing and that ends up invalidating some previous parts that you mentioned. One thing that I've mentioned previously is that what you can do is look at the number of points available for the question. You can kind of estimate this based off of the number of parts and how much the question's worth altogether. And the number of points the question's worth will dictate how many unique statements you need. So a 7 point question needs, at minimum, seven unique statements said. Um, so you kind of want to try and keep to that limit. All right, so here's some examples of what I meant by some of the phrasing that they might use. So things like saying describe or explain something usually means that they want what's called an accurate and coherent description. Um, they want you writing in full, complete sentences and stating key terms. And this is pretty much the main idea. So anytime you're seeing this, they want it in words, in sentences. They want what that means is that they don't really want you using equations to kind of back up what you're doing. So if they ask you, explain why the acceleration goes up, they don't want you just saying or showing F net equals ma and then like examples of how as the force goes up, the acceleration goes up. They want in words what's going on. Justify is another way that you pretty much defend almost an argument, and you have to provide evidence for this. So when they say justify, that means that you're allowed a few things. You can state a principle. You could go back to one of Newton's laws as a justification. You can do equations and kind of show, hey, based off of this work, this is a good justification for why I think this. Using graphs and diagrams, all these things. So when they say justify, you are now allowed to use brief sentences and equations and or equations, as long as it's following again the logic of what's happening and someone can follow how you took that information to get your what you state your statement. Calculate is basically when they want an answer and they want you to show all your work. So you can kind of start to see how the different phrasing now kind of relates whether or not they're looking for wording or equations or maybe a little bit of both. So with the calculation, when they say calculate, they want you to see a proper equation. So that means equations coming straight from the reference table. They want you to put the numbers and substitute into that equation, making sure that those numbers have their proper units. Things like the answer with units. Now, it's important to remember that the key thing here is that you need proper equations. Equations that are not found on the reference table are not considered proper equations. A lot of times, what they'll be called is derived equations. So there are a few cases where we might simplify equations right from the get-go. You might memorize equations in a more simplified way, but that might be considered a derived equation rather than a proper equation. So you want to pay attention to that. Always at least write down whatever the equation is from the reference table. You can manipulate it later. So derive is something that when you see that word derive, what they kind of want you to do is come up with some new equation using some of the other equations that we have. So, for example, they may want to derive an equation that relates the kinetic energy with height. There is no equation on the reference table, so they expect you to use other equations on there, combine them together, kind of manipulate them around using basic algebra in order to repurpose the equation so that you get kinetic energy on one side and height on the other. Basically, the way I always describe this is that it's solving algebraically for something. So, doing the same type of thing you would have done if I gave you numbers, just without the numbers. Determine or what is. Usually, when you see that phrasing, that's pretty much kind of hinting that you don't that they only want an answer and they don't need to see any work. They don't need to see any explanation. Nothing. Usually, these types of questions are like 1 point questions, and the calculations are typically on the lighter end. And kind of as it says here, it's usually just a statement that you have to make. Just like with everything, sig figs don't matter at all in this class, though you do want to try to keep all your significant figures to about 2 to 4 sig figs. If you put 3 and all the other numbers are in have 4 sig figs, no one's going to really take off points for you. But you just want to make sure that you have at least enough numbers, enough digits in your number to make it somewhat unique. If you take a number that they consider to be correct as 1250 and you round it all the way up to just say it's 1000, they may not consider that appropriate enough because that amount of rounding has gotten rid of so much information and made the number vastly different. Design and outline is the phrasing that they use when they want you to end up coming up with a procedure for some sort of experiment. So this is your designing experiment type setup. They want you to do it in a somewhat orderly way so that someone can read your passage and then perform this experiment. Now, there are a bunch of things that they are looking for whenever they tell you to design or outline a procedure. They want things like multiple trials. They want graphs, which for the most part, not every experiment requires a graph, but a ton of them do. So you want to try and find a way to incorporate it. You want to be able to include lines of best fit and all that stuff. Now, going back to here, one thing I did want to point out is though they do want you to write down it in step form, they don't want it as 1, do this, 2, do that. They do want it a little bit more in like a paragraph type explanation. So just keep that in mind. Sketch is pretty straightforward. Usually they want you to kind of draw a graph of what's going on, but there's really not supposed to be any data and numbers in there. It's variables on the x and y axis, and it's really only meant to show the trend between something. So they want you to sketch the relationship between kinetic energy and velocity. You just show that it's an exponential curve. Things like that. Yeah. There really shouldn't be any information on there unless they explicitly say it. There are a few times where they might have you label a certain time to be a moment, like when two carts collide. So maybe they want you to sketch the before and after of the momentum of these two carts. So there might be a little bit of data, but usually it's not nearly as detailed as plotting. Plotting is where they want you to actually have a full-on graph. You have grids, you get your data in there, you have to label the axes, you have to do the whole 9 yards here. And normally once you plot something, you have to remember that you're going to be using the graph. There's no reason to make a graph and then not use it. So usually the follow-up question is going to be something about taking the slope, taking the area, uh, line of best fit, could be doing a y-intercept. Anything that you can get from that graph, you're going to try to calculate something from it so it could be used. Uh, as I've said previously, it's very common that you might find that you have to actually manipulate the data before you can plot it. What I mean by this is, remember that sometimes when you try to plot two variables, you'll end up having an inverse relationship or an exponential relationship, both of which, or I should say, neither of which, we can accurately form fit a curve to, uh, at least on paper, without the use of some sort of program. So instead, what you can do is alter the axes so that you end up getting a linear graph, which we then can take the slope of so that we can calculate whatever we need. So keep that in mind. That's also a big thing in this type of question. All right, this one's actually going to be really important because it's pretty much going to be guaranteed in I would say almost any free response question. Draw and label. So this is usually related to free body diagrams. I don't think that you'll see any type of vector diagrams here, or I shouldn't say vector diagrams. I meant more like displacement diagrams. This is more for, they give you a box and they want you to draw all the forces acting on it. Now, the important thing is there's a few important things here. First, even though the arrows normally don't have to be the exact same size, they should end up reflecting that relative size. Meaning, if one force is bigger than another, you want to make sure that that arrow is exaggerated to dictate that. So, let's say you have two people pulling on a box. You have two people pulling on a box. One's pulling with the force of 10 newtons, the other one is 15 newtons. You wouldn't make it only slightly bigger because it's hard to tell that this is supposed to be bigger than that. You would extremely elongate it like that. The main reason is that normally when they want you to draw and label, you don't normally label it with the values. You would label this as, the force of the kid, and this would be the force from the adult. So you can kind of see from here, very clearly which one's the bigger value, what direction that bigger value is. You can identify the general direction of the net force and all this information. Now, the important thing is that you do not include components in your FBD. This seems a little bit counterintuitive because one of the things that you'll learn when we get to the forces is that I always tell you to break up any forces that are at angles into their components. This may not make much sense right now, but it's something that you end up doing. You have something at an angle, you break it up into X and Y so that you can actually work with it. But when you're doing the diagram for someone else, it has to have the proper forces, no components, nothing like that. Uh, Here, it turns out that they'll actually take a point away for each additional vector. So that could be a lot. Uh, so just keep this in mind. Like I said, there's a few cases where this pops up, and I'll be making sure to kind of reiterate that. If you Because the FBD is so important for you on your end to actually be able to solve the problems, usually what I tell you is that if you're being asked to draw an FBD, you draw the FBD for the person, and then somewhere completely different is where you draw the FBD for you. And when you do the FBD for yourself, then you can break these forces into their components and do all this other stuff. So just keep in mind that you draw the FBD properly for the person, for the other person, and then you never edit it at all because the last thing you want to do is start writing on there. And that's pretty much it. So, like I said, throughout this class, you're going to see me try to give examples of this. The difference between describe, explain, justify, calculate, things like that. Because, like I said, each one carries different criteria. If you try to use an equation in a question that's telling you to explain, you're going to lose points. If you try to use words in a question that's asking you to calculate, you're going to start losing points. So uh, just try to keep this in mind, but no, you'll end up getting used to it eventually. If you have any questions, feel free to let me know. Otherwise, good luck. Have a great day.